Okay, 1.4C is in Charlie. In college algebra, we are on bottom of page 64, talking about the general forms of an equation. All right, so we have all kinds of different ways to basically write the same thing. If you look at the top of page 65, it gives you what these forms look like. So I just want to look at general form of an equation just for a minute. And so we've got, let's say that we have a slope-intercept form of equation as this, which is y equals mx plus b in that format. If we want to change it to what is called the general form, then the general form looks like this, where a, b, and c are numbers. We don't know what they are right now, so we're going to call them a, b, and c. X and y will stay x and y. So what we're going to do is we're going to change this form to this form. So we're going to multiply the entire thing here by 3 to get rid of the fraction. We're going to move the 2x over. Okay, so that's all I did so far. It's looking a lot like this. The only bad thing about it is this doggone negative. Now, if I want to change that negative to a positive, all I do is change every sign in the entire equation to its opposite, and I can do that. Okay, what I did basically is multiply the entire equation by -1. And when I did that, it changed this 2 to a positive, this +3 to a negative, and the 7 to a negative. So that's really what I did here. It's just nice to have the leading term, the first term, a positive number rather than a negative. And if you look at the top of page 65, it gives you, and I would put these in my notes, it gives you 5 different forms of linear equations. Very, very important. Okay, middle of 65, average rate of change. Okay, up until this point, we have done what is called a constant rate of change. That means we have a linear equation. Every time we go over this far, we go up this far. I mean, it's always the exact same. All right, now we're going to do something a little bit different. We're going to call it the average rate of change because the rate of change may not be consistent. It may be something that when we graph it, it looks like this. Notice that as we go over and up, the rate of change changes a lot. So, for example, if we go over this much, our y goes up here. But down here, if we go over this much, see how my distance here in y is different? So, when they are different like that, we're trying to find out what the average rate of change, okay? So, it may look like a line like that. And when we make a line that is the average rate of change, it is called and maybe this is from your trig days, a secant line, okay? That is the average rate of change between 2 points on a graph, okay? So here are my 2 points, and that line is called a secant line. So this is where it starts to get a little hairy. I'll try to explain it as well as I can. The average rate of change, middle of page 65, where it says average rate of change, notice what my top number says, or my numerator says. A change in f of x values, or basically my change in y, over my change in x. Now we used that earlier to determine slope. And that's why I gave this to you, is because it would come in handy later. So, what this means, in the book has it written as f of b minus f of a over b minus a. Okay, so what they're saying there, and see if I can draw a graph here and kind of give you an idea. If we go over, let's say that we have a point here, and the distance from here to here is a, which means the distance from here to here is y, or the function of a. Okay? My f of b, let's put it in blue here, would be my distance here, and my y value then would be my function of that b. Okay, so if I'm trying to find the average rate of change between these 2 points, I'm going to take my y value, my distance from here to here, okay, f of b, put that number there, minus my f of a. Okay, and what that will give me is this distance from here to here. Okay, that's what that will give me. Okay, and I'm also doing it down here. I'm taking the distance of b minus the distance of a, which again, I'll do this in black, which gives me this length right here. Okay, so that is the average rate of change. Okay, and then I talked about the average rate of change for any function between 2 points on a graph is the slope of the line joining these 2 points. So what I'm going to do then is I'm going to want to find this line here. I want to find the slope of that line. And the slope of that line will be my average rate of change. And, again, this line right here is my secant line. Okay? All right. Hopefully that'll make more sense as we continue on. Okay, so looking at example number 9, difference quotient. I'm going to kind of go a little bit backwards here. I'm going to explain it before I give you the difference quotient. And I don't like the graph that they have here for example 9, so I'm kind of making up my own to explain what we're doing, and then we'll go back to the example that they give us and actually do it. So I just think it's easier to explain it using what I have here. Okay, so let's say that we have this point. Let's put it in green, and let's say our point is right here. All right, so this point, we came over x, and we went up f of x. So this is point x, f of x. Okay, that's the point that we have right there. Okay, if we had a number, we could say it's 2, 3 or something. All right, and we're going to put another point right there. I'm going to move this over a little bit. And let's say that this point here is the distance from here to here, which is x, plus another distance. Okay, we don't know what that length is, but we're comparing it to this. So it's this distance plus this distance. So what we're going to do is we're going to call this distance right here h. So we'll call this x and that h. So to get over to this point, we had to go x plus h. So that is going to be our x, or our first value there. And our second value will be f of x plus h. Okay? So now I have 2 points here. I've got x, f of x, and I have x plus h, which is the distance all the way here, and then the function of x plus h. Okay, my y value basically from here to here. Okay, so I have that. If I'm interested in finding the average rate of change, it would be basically the slope from here to here, from this point to this point. Okay, the thing that makes this tricky is they just give you all these letters here. And so it makes it really hard unless you have numbers to really figure out what's going on. Okay, so if you remember right, and I'll do this in black here, this line from here to here, which is the average rate of change, is also called the secant line. And what we're interested in is finding the slope of the secant line. Okay, that will be the average rate of change, the slope of the secant line. Okay, so in order to do that, we use what is called the difference quotient. And what we're going to do is we're going to use the x, the h, the x plus h, and the f of x plus h in the formula here. So let's write the formula here so we can make sure we've got this. We're going to take the y value of 1 point, f of x plus h, minus the y value of the second. So the difference in y's over x plus h, okay, one of our x values, minus the other one. So the change in x. Okay, so you've seen that before. We just wrote it in a different way. When you take an x minus an x, that ends up being 0. So we can get rid of that. And that ends up being our difference quotient right there. So all we're doing then is taking this value, whatever number that is, minus this value over whatever our h is, the different distance between here and here. Okay, so let's go ahead and look at example 10. Let me get rid of this junk. And we have, for the function, f of x equals x squared plus 1, whose graph is shown in 1.41, which you can see there. Find a f of x plus h. Okay, let's do that first. So what we're going to do, what this means is whenever we see an x in this equation, so that's what this says, we're going to put an x plus h in its place. Okay, so this is going to look like this. So instead of an x, we're going to put an x plus h. Okay, not so hard. And then we're going to do, we're going to square x plus h times x plus h, do the whole FOIL method, and you will get that. So that is the f of x plus h. All right, we need to hold on to that. We're going to need that later possibly. All right, B. Find f of x plus h minus f of x. Okay, so we know what f of x plus h is. We found it right here. What is f of x? Okay, f of x is x squared plus 1 from the very beginning, right there, f of x. So what that means is we're going to take x squared plus 2xh plus h squared plus 1, because that's our f of x plus h. And then it says we're going to subtract x squared plus 1, which is our f of x right there. So we're going to put all this together, combine like terms, get rid of stuff we don't need, and we're going to get that. Okay, so we're going to hold on to that as well. So, the slope of the secant line. Remember what the slope of the secant line is. It is using the formula okay? So, what do we know? F of x plus h minus f of x is going to be, let me get my pen here, this thing, because this is f of x plus h, this minus f of x. And then that's going to be over h. All right, so f of x plus h minus f of x, that's what we have here, is this here. So we already did that earlier in B, so we can just write that as, okay? So that's nice that we did that in B, so we don't have to redo it, over h. The only thing we have to do now is factor that h out of the numerator. cancel those, and that's what we have for an answer. That is the slope of the secant line and the average rate of change. All right, so again, I had mentioned this before. This is a precursor to calculus. When you start doing calculus, you will learn the difference quotient and practice it and practice it and practice it. And then this is always the bad news. Later on, they'll give you a real fast and easy way to do this. But at this point, you're kind of doing it the long way to get used to it and familiar with it. So anyway, this is giving you a little bit of a head start, and that's it for 1.4C, and we'll continue with 1.4D.